Have you ever been on a bus that suddenly starts moving? You feel like you're being pulled backward. Or maybe you've noticed how tough it is to push a heavy suitcase compared to an empty one. These everyday moments are all thanks to a property called inertia. Hello, learners. Today, we are diving into a concept that quietly governs almost everything around us, from standing still to moving fast. It's called inertia, the resistance of a body to any change in its state of rest or motion. Let's say an object is resting peacefully. It wants to stay at rest. Now give it a little nudge. Unless you apply a strong enough force, it resists that change. That's inertia. The same idea works in reverse. A moving object wants to keep moving. Unless friction, a resistance, or a wall stops it. Inertia is nature's way of saying, let me be. Don't disturb my state. But what decides how much inertia a body has? Let's find out. Let's go back to the suitcase example. You're trying to move a small one, easy. Now switch to the big one. Suddenly it feels like the suitcase has decided not to move. But what's really changed? That's right, mass. The heavier the object, the greater its inertia. It's a direct relationship. So, if you want to know how much resistance a body offers to motion, just look at its mass. That's why we say mass is a measure of inertia. More mass, more inertia. Less mass, less resistance. It's not about size or volume, it's about the quantity of matter in the body. This simple truth explains why a small soccer ball can be kicked easily, while a concrete sphere of the same size barely budges. Let's compare two common sports balls, a cricket ball and a tennis ball. Now imagine you apply the same push, same force, same time to both. What do you observe? The tennis ball zips away with higher speed. The cricket ball? Slower. Why? Because the cricket ball has more mass and hence more inertia. And now, let's flip the scene. Both balls are rolling at the same speed. Which one is harder to stop? You guessed it, the cricket ball again. It resists the effort to stop it because it carries more inertia with it. As you see in the slide visual, equal force means unequal velocity, simply because mass influences how much a body can resist acceleration or deceleration. Picture yourself at the airport. You've got a luggage trolley. The first one is empty. You give it a push and it glides smoothly. Now the second one is loaded with bags. You push just as hard, but this time it barely moves. Why? Because the loaded trolley has more mass and therefore more inertia. It resists your push. And when it's already moving, it also takes more effort to bring it to a stop. This real-world example proves it. Whether you're starting motion or stopping it, greater mass means greater inertia. Look at the slide here. It shows two trolleys side by side. The one with higher mass needs a bigger force arrow to get moving or to come to a halt. This is why trains take time to stop and trucks need powerful brakes. It's all about managing inertia. Let's clear up some confusion. Students often ask, is inertia a force? The answer is no. Inertia is not a force. It's a property of matter. It doesn't push. It doesn't pull. It just resists. Also, just because a body has more inertia doesn't mean it moves faster. In fact, it means it's harder to move or stop. The force required to change motion depends on mass. According to Newton's second law, F equals m into A, where F is the force in newtons, m is mass in kilograms, and A is acceleration in meters per second squared. So if mass increases, the force required increases too. More mass, more inertia, more force needed to change motion. Let's bring it all together. Inertia is a body's resistance to changes in motion or rest. The amount of inertia depends entirely on mass. The more, the more resistance. We explored how a cricket ball behaves differently from a tennis ball and how loaded trolleys are harder to handle than empty ones. We clarified that inertia is not a force, but it determines how much force is needed to create motion. You experience inertia every day, when your backpack pulls you backward as you jump, or when a bus throws you forward after a sudden brake. Understanding mass and inertia is like holding the key to unlock motion itself. I hope this lesson has helped you feel the physics behind motion, not just memorize it. See you in the next session, where we'll push forward into more powerful laws of motion, literally and conceptually.